Assalamu alaikum. My name is Zain Said and I am a structural engineer currently serving the University of Lahore as assistant professor in the civil engineering department. And for last 7 years, I've been engaged with the design industry as well. So constantly मैं local industry or international industry के साथ link था. For 2 years, I've been in Qatar as a design coordinator on Qatar Rail Metro project. And before that, I have worked for National Highway Authority for designing highway structures, including bridges and culverts and high-rise retaining walls. For past 3 years, I have been part of University of Lahore and teaching their undergraduate civil engineering students. So today we will going to see some basics about Etab. I'll just start with the small presentation, and later on, once we quickly go through that position, we will move towards actual software, and we'll look into the interface and other things, what Etabs have, and quickly go through all these things. So let's start with the presentation right now. I hope the screen is visible to all of you. In this lecture, we will just see some of the terminologies, basic, which are related to Etabs, what are the applications, some of the commands, and in more detail, we're going to look into the software once we finish this presentation. So first of all, the product is from a CSI company, and they have various products for building design and other structural members, like this particular software, Etabs. It is for particularly for building design. It is a frame structure software. So you are able to design beams and columns. And nowadays, because they have done so many modifications from previous version, like in 9.7.4 and other versions, you are not able to calculate the footings and slabs there. So CSI have a different product for that thing. Like they have a CSI safe software. So that was used for designing different kind of floor systems, including waffle slabs, flat plate slab systems. And basically both of these softwares, they are interconnected. Like you can export from Etabs and then import that model into safe and design things over there, because they are under the same company, CSI. That's why they have the same compatibility. But nowadays they integrated all these things in one version, like Etab 2013, 15, 16 version. If you go through these versions, so now these versions are capable not only to design these frame structures, like you can design beams, columns there over there, and even that you can design footings over there, and floor systems as well. I would suggest कि जिस तरह markets के अंदर crack versions available होते हैं, just learn from them. Once you go to a big organization and you're working over there, try to purchase this software, because there are so many efforts people are doing in building these kind of softwares. ठीक होगा जी? So let's start with the introduction of Etabs. As I already told you that this is finite element program, and we have to divide these structures into finite pieces. The one we call it meshing in software. We call this as meshing. Like there are nodes here. Once we combine these nodes, they form elements, and once these elements are combined, they form surfaces or plates, something like that. The software is a precise one. It is capable to produce the reactions, the shear force diagram, the bending moment diagrams. You can apply loads on the structures and see the deflections, like serviceability states. You can check them. Once the design request is completed, you can even check like how much steel is required in the sections. So this has a precision and accuracy. But keeping in mind this term, like this is precise and accurate, you should know that being a structural engineer, because every FEM software, every tool that you are working, they have a sense like it's garbage in and garbage out thing. Like if you are entering wrong inputs in them, so you will get wrong outputs. तो इस चीज़ का हमेशा ख्याल रखें कि whenever you are dealing with any kind of software, I'm not talking about Etabs, it's all about any kind of tool that you are using. So you should know the background, what kind of formulas are being used to calculate these things, the response, how the responses have been calculated, what kind of inputs, in what format the input should be given. Because if you are giving the inputs in a wrong format, आप wrong inputs देंगे, so you will get the wrong outputs. So keep in mind whatever software you are using, just make sure कि आपको कुछ manual चीज़ें आपको आती हों. ठीक है जी, like you should know if there is a beam column and it has a fixed connection from both ends, like there is a beam with fixity on both sides. So you should know like what kind of bending moment diagram it should have. It should have negative moments at the supports and positive moments at the midspan. So आई एम नॉट टॉकिंग कि आप सॉफ्टवेयर की एक्यूरेसी को वहाँ पर आकर जज करना स्टार्ट कर दें कि नहीं इसने सही कैलकुलेट की कि नहीं, बट आई एम सेइंग कि वंस एक बिल्डिंग जो आपने मॉडल की डिज़ाइन की, लाइक इट हैज़ 300 and 400 beams, so once you see their bending moment diagram, just look at their pattern कि वो पैटर्न ठीक भी आ रहा है कि नहीं आ रहा, ठीक है. If there is some mistakes in the pattern, means maybe there is some मिस्टेक्स इन योर इनपुट्स, आपने लोडिंग के अंदर कोई मिस्टेक कर दी है, मे बी शायद आपने उस लोड को गलत लगा दिया है, ठीक है, और मे बी द सॉफ्टवेयर इज हैज सम बग्स, इसके अंदर कोई बग्स भी हो सकते हैं, ठीक है. सो बी केयरफुल अबाउट दीज थिंग्स. That's why I always suggest people and students, like once you are in a professional life and using these tools, just counter check them with some manual checks. छोटे छोटे manual checks लगा लें. The importance of manual checks ये नहीं है कि आपके 100% results ETABS के साथ मैच करें. एज उल्टे टूल के Etabs एक प्रिसाइज सॉफ्टवेयर है, उसके रिजल्ट बड़े एक्यूरेट आएंगे, बट वंस यू आर डूइंग सम मैनुअल कैलकुलेशन, आप उसके अंदर कुछ अजम्पशंस कर करके छोटी चीज़ों को उसके करीब लेकर आएंगे. सो द सॉफ्टवेयर इसके कुछ फेजेस हैं जिसको हम डिवाइड कर लेते हैं. दैट इट इज़ कैपेबल ऑफ मॉडलिंग थिंग्स, यू कैन डू एनालिसिस, डिज़ाइन एंड डिटेलिंग. ये बेसिक कैटेगरीज हैं जिसके अंदर हम इसके स्टेप्स को डिवाइड कर लेते हैं. फॉर द मॉडलिंग यू आर एबल टू, फॉर मॉडलिंग मीन्स you have to create some beams, columns, because जब भी आपने किसी स्ट्रक्चर को एनालाइज करना है, like if you want to check the response of the structure, so the response should be against some loading, यानी applied load आप उस पर लगाएंगे, applied deformations लगाएंगे. so किसी स्ट्रक्चर के ऊपर लोडिंग उसी वक्त लगेंगे जब आप स्ट्रक्चर को फर्स्ट मॉडल करेंगे. so in Etabs you need to first model things, like you need to have trial sections, और आप उन ट्रायल सेक्शंस यानी कॉलम्स को मॉडल करेंगे, ट्रायल सेक्शन बीम्स को मॉडल करेंगे, स्लैब लगाएंगे, एंड देन लोड्स असाइन करेंगे. सो दिस सॉफ्टवेयर इज कैपेबल ऑफ मॉडलिंग दीज जॉइंट्स, फ्रेम्स. You can even form two-dimensional beams, columns, braces. It can even model tendons. For example, you have a post-tension slab that you have to design flat plate slab system. So there are tendons going on throughout the slab system. So you can even model these things in Etabs. So the software is capable of modeling these line elements. We call them as line elements and area elements. Like the beams and column, they are classified as line elements, and the slab thing, it is classified as area elements. So these are the modeling things. In analysis, there are different analysis, seismic analysis, which are being specified by the codes, which include like linear static and non-linear static, then dynamic and linear dynamic and non-linear dynamics. So all these different kind of seismic analysis, these can be performed in Etabs. And the basic one which we commonly use is a linear static procedure, which is equivalent lateral force procedure, which is being used like 80-70% of your buildings, they are being designed on this thing. Once you go to higher number of stories, and there are some irregularities in the buildings plan, so then you need to go to some further higher seismic analysis procedure. Like you need to sometime go for a pushover analysis, which is static but a non-linear method. Then there are response spectrum, time history analysis. All these different kind of seismic analysis, these can be performed in Etabs. Then we go for the design process. Once the analysis is complete, the next stage is the design. The output of this analysis, basically you will get the deformations, like you are able to see how much the nodes have been deformed due to certain load cases, and how much are the base reactions, like you have applied area loads on the structure, and ultimately you want to know like how much is the base reaction. Like once you need to design the footing, you need to know the values of the base reaction, like what is the reaction coming under the columns. So after doing this analysis, you will able to get all these information from your Etab models. Even you are able to see the shear force diagrams and bending moment diagrams for all of your beams and columns in just one click. If there are like 1,000 members, you can see the shear force and bending moment diagram for all those 1,000 members at one click. So next we will move toward the design phase. Once the analysis phase is completed, like you get the response of your structure. So keeping in mind, you will go for the design check. And in the first stage, you have taken some trial sections. So if some of the members, they are failing, like the Etabs will show you like it is failing in shear, maybe it is failing in flexure or something. So you need to increase the sizes of those members trial sections. So in this analysis and design phase, you will ultimately playing with the trial sizes what you have taken in the modeling stage, and ultimately you will finalize your sections in this thing. Once the design phase, in the design phase, it's further classifying, like you are able to do these steel frame design, concrete frame design. The one we will be talking in this session is mostly concrete frame design. Even you can do composite structures in Etabs, like there is a reinforced concrete column and it has a steel section, like a steel structure. So steel structure is embedded inside a concrete column, so it is a composite column, so you can even design those structures in Etabs. The last phase is the detailing, like this detailing has been incorporated in the latest new versions of Etabs. Like if you go for the 9.7.4, the one I will show you right now after this session, it is not capable of doing this detailing thing. Detailing means like against the design, because once the design is completed, ETAB will show you like this much percentage of reinforcement is required in column, this much reinforcement is required in beam, the top reinforcement is this one, bottom reinforcement is this one. This information is insufficient, because if you share the same information to site construction industry, like you instead of sending those structural drawings, you tell them like, okay, this is a beam, provide 2.5% on left end, 1.5 on the right end, 3.5% on the bottom. So they will not be able to understand these things until you provide them a drawing which is showing a longitudinal section, cross section, the dimensions of the beam, how many numbers of bars have been placed in the bottom, how many bars are placed in the top, what is the stirrup spacing. So all this comes under detailing things. So the new versions, they are capable of doing all this detailing automatically. You just need to adjust some of the parameters, like you want number 3 bars or number 5 bars in beams, or you want number 4 bars in columns, something like that. So you will adjust some of the parameters, and just on few clicks you are able to get the drawings from ETAB. It will create a huge number of drawings, like 30-40 drawings for you, which have these sections, longitudinal and cross section, everything for you. Coming towards further activities, like अगर हम ETABs के बारे में देखते हैं तो ओवरव्यू मैंने आपको जिस तरह स्टार्टिंग में दिया, templates and defaults. I will show you in ETABs, like there are templates. Instead of modeling from scratch, अगर आप बिल्डिंग को बिल्कुल scratch से मॉडल नहीं करना चाहते, you just select one of the template, like I want to design a flat plate slab system. So instead of starting from modeling columns and beams and everything, there is a template there, just select it. So it will automatically form beams, columns, and everything. So there are some templates I will show you. So graphical user interface, this will also see in the next session. You need to be very careful with the systems of units, because sometimes there are units which are being displayed at the bottom of the screen, and sometimes once you are activating a command, so the dialog box will appear, and there are certain units over there as well. The activities in modeling is like you need to first model the grids. जब भी आपके पास कोई structural design करने के लिए आएगा, so you first need to have grids in them, like architectural drawings complete होके आपके पास आएंगी. So sometimes you will see the grids are passing through columns. यानी आर्किटेक्ट ने कुछ जगह पर कॉलम्स मार्क कर दिए होते हैं, और बेसिकली उसने मार्क किए होते हैं, डिजाइन नहीं किए होते, और ना इवन उसने कोई साइज लिखा होता है. द पर्पस ऑफ दोज मार्किंग इज जस्ट टू लेट द स्ट्रक्चर इंजीनियर नो दैट these are the possible places where you can place the columns. In the rest of the areas, please try to avoid putting columns there. And if the structural engineer see them, okay यार मैं जहाँ मुझे आर्किटेक्ट ने कॉलम्स दिए मैंने वहाँ प्लेस कर दिए, बट स्टिल द बिल्डिंग इज नॉट सेटिस्फाइंग and I need to insert some new columns, or I need to insert a new grid line. So he will discuss with the architect like, okay, I need a column in this hall, because if I don't provide this column, maybe the overall structure performance, it will be compensated. So they will discuss with each other and see what things can be compromised over there. So first thing is that you will model grids in Etabs. I will show you in the next session once I will open the Etabs. You can edit stories, and add and edit stories mean multiple stories can be made in Etabs in quick way. Like if you have a building with same floor plans all over the 15 floors, so you just need to adjust one plan and let Etab know like you have 16 similar floor plans, so it will create automatically 16 similar floor plans for you. The good option in Etab is like it has option of replicate. You can completely select a floor. even you can select few columns, few beams, and replicate them in next stories, upper stories. Another option is extrusion, because it's a 3-dimensional software, and it will actually show you once you have completed modeling, so you can see the extruded model of your building, realistic modeling. तो इसको भी हम देखेंगे. This is very good option there. You need to define properties, because the concrete and beam, once you are going to draw a beam or column, it will automatically, first thing it will ask you, like if it's a beam, then let me know, like is it a concrete beam? If it's a concrete beam, how much is the strength? So these are something that you need to define before defining sectional properties. Like before defining columns, beams, slabs, the trial section, you need to define material properties. So because we are using concrete for reinforced concrete structures, so we can either define 3000 psi concrete and 4000 psi, because most of the buildings that you see outside, multi-story buildings, they have 4000 psi concrete in columns, a higher strength in columns and comparatively lower strength in beams and slabs and footings. Like 3000 psi concrete is being used all over the structure, except for columns, they have comparatively high strength. So it can be like 4000, some in high-rise building it goes 6000 psi as well. So you need to define material properties. Then once it is being done, then go for sectional properties. Sectional properties mean you will define some trial sections. Then the connection is unstable. Then once it's been done, there are load patterns and load combinations. The purpose of these load combination is to simulate different possible worst scenarios that the structure will experience in its service life. Every structure have like a design life. For example, we have buildings, they have 30 years, like bridges 50 years, railway structures, they have 100-year lives. So during their service life, they experience some worst scenarios. All these scenarios should be simulated in these FEM softwares through these load combinations. Okay, this is all, it's fine. Okay, let's move on. Once you finish your Etab works, just make sure like these things have been done. So it's kind of a checklist. Now moving towards the key features, because I already told you, like it's a 3D model. You can see plan views and 3-dimensional views as well. Another feature of this Etab software is like you can import CAD drawings. For example, if you don't want to waste some time in making the grids and floor plans, you can import the CAD file of those grids into your Etabs and then extrude them into a 3D model. So CAD files can be imported in Etabs after doing some adjustment in CAD. It's not like that कि आपके पास जो भी CAD file आपने Architect से उसको directly import करेंगे, because that CAD file is containing so many objects. उसमें विंडोज भी हैं, उसके अंदर ब्रिक वॉल्स भी शो हुई हैं, उसमें कॉलम्स, हर चीज़ है. सो यू जस्ट नीड सम ग्रिड लाइंस एंड कॉलम्स देयर. तो आपने उसको थोड़ी सी एडजस्टमेंट करनी है. यू नीड सम एडजस्टमेंट टू बी डन ऑन दोज कैड ड्राइंग्स, एंड वंस इट इज डन and cleared from all irrelevant things, then those CAD drawings can be imported in Etabs as well. These are different analysis that can be done in Etabs. I already told you that linear static analysis, this is equivalent lateral force procedure. Then there's a linear dynamic analysis, static and dynamic P delta analysis can be done on Etabs. There's a pushover analysis, which is being done to check the performance of existing buildings. Then there are multiple response spectrum, time history analysis. All these can be done on these softwares. This is a real building which is being constructed, and you can see on the lower part there is the FEM software, FEM model of the same building. So they look very similar to each other. This is another feature of Etabs, that you can see the model created, and it looks very similar to the once it's been completed on site as well. Similar story concept is like this one. For example, if you have a 30-story building, and for first 10 floors, they have some commercial activities. So they have shops over there. So all the 10 floors, they have very similar floor plan. Okay? और जैसे 10 से आप 20 तक जाते हैं, so they have like offices over there. तो offices के flooring जो उसकी जो floor system होगा, या उसके ऊपर जो plan हुआ है, it is different from shops. ठीक है? तो मगर आपस में उन 10 का, यानी 10 से लेकर 20 तक फ्लोर सिस्टम सारे सेम होंगे. ठीक है? Then from 21 to 30 stories, maybe they have some residential suites. So residential suites के अंदर अगर आप floor plans देखेंगे उसके, so they will be different from offices and they will be even different from the shops. मगर आपस में यानी floor plans वो same होंगे यानी 21 से 36. So you can define in Etabs like three different यानी इस building के लिए जिसको मैं भी discuss कर रहा था कि जिसमें 30 stories हैं. So you can define three master stories. For example, मैं story number 1 को master story कहूँगा. And whatever I'm doing on master story 1, it will be replicated automatically story 1, 2, 3 up to story 10. So the second story that I will create, it is master story 11 से लेके वो फिर 20 तक सारों को एक जैसा ही मॉडल करना स्टार्ट करेगा. So this thing we will cover in next session as well. Parametric templates, जिस तरह मैंने पहले बताया, you have these templates like you can model the baffle slab, rib slabs and flat slabs quickly in Etabs. And तो ये ऑप्शन हम जाके ETAB के अंदर देखेंगे. These are some of the pictures that have been taken from ETABs. This is a steel deck. This is a flat slab system. You can see even the drop panels here. This is a waffle slab systems and staggered truss systems and flat slab systems. Realistic modeling, as I already told you, this is a building which is under construction, and this is the view from ETAB. So you can see these the yellow ones. These are the columns. It's very it's looking very similar to the model here. Powerful view options, like you are able to see plans and elevations simultaneously in Etabs. यानी उनके यहाँ different screens हैं. From on left screen you can even see the elevation, on right screen you can see the floor plans. So maybe if you want to see floor plans on left screen, on the right screen you want to see the 3D model, you can even see that as well. Okay. Flexible grid system, you can even have rectangular, which is called a Cartesian grid systems. And if the building is in a curved form, so you can have cylindrical grid system as well. And the third option they have is a general grid system. Like if you want to make the building such that you don't know if it's not lying in perpendicular, like if it's not under Cartesian systems or not cylindrical system, so you can form your own grids. This comes under general grid system. So the basic one which are mostly being used in buildings, this is the Cartesian one, because most of the building that you will see around yourself, they are rectangular squares. So few of the building, they are in curved, because the structural performance, it's been very much affected by the shape of the building. So most of the building, they are like squares and rectangulars in shape. So this option, Cartesian grid system, this will satisfy most of your purposes. But in some cases, if there are some curves in the building, so you can have this cylindrical grid system as well combined with your Cartesian grid. Extensive section database. The software itself, it has a big section database for designing steel structures, because we have W sections, I sections. They have a different variants in them. Like आपके पास एक ही W section की पूरी series है, I sections की series है, L section channel sections की series होती है, जो standard sections use किए जाते हैं AISC के अंदर. So all those sections are already existing in the database. So if there is a structure and steel structure है, let's say मैं example देता हूँ, and you are just going to design beams over there, और लेट से आप कहते हैं कि वहाँ पर आपने सारे W sections use करने, so you will just tell ETAB कि ये मेरे पास पूरी list है, just select from this list most economical section. ठीक है, instead of giving it a trial section, you can even select a complete list. ठीक है, उस database में से, और उसको बताएंगे कि हाँ सिर्फ W sections के अंदर से मुझे जो most economical section है according to loading and according to requirement of this structure, वो select करके इस पे लगाओ. So it can do this as well. Addition to this, you can form your own sections. This some concrete structures में आते हैं. You mostly have these rectangular and square beams and columns and slabs. So you can form them. Even you can form composite columns as well in Etabs. These are the different loading things, like you can apply line loads on Etabs. You have the options of applying area loads like a pressure loads. You can define seismic loads, and Etabs will automatically apply those loads, seismic loads, and even the wind loads on your structures. ठीक है, आपने सिर्फ उनकी definitions देंगे, like you have to tell Etabs like your building is this thing in this zone, the soil profile is this type, the structural system is this number, so how many stories are these. So based on these things, it will automatically calculate, and it will automatically apply seismic loads on your buildings. There are different load codes that are being incorporated in this Etabs. Once you open this dialog box, it has UBC 97, ASCE, all these different codes. They have been incorporated in this one ASCE. Like sometimes some people they prefer to have the winds applied on this ASE system. Some people they prefer to use UBC 97. So depending upon the prevailing code, you will select one out of them, and based on the inputs you have given, it will apply those seismic and lateral loads on your buildings. Okay, nothing special here. We will talk about it later. Once you are drawing your slabs, it has different three options. Like even you can draw those slab as a membrane. It will ask you like select one of the option. Like the slab you are drawing, it is having a membrane property, it is a shell property or plate property. Most of the times you have read all these things difference in your undergraduate studies. They have a difference. आपके पास membrane है, it has in plane stiffness. The shell, it has in plane and out plane stiffness as well. Both plane के अंदर होती हैं. And this is basically depicting the real situation. जो आपकी real world के अंदर slabs होती हैं, they have in plane and out of plane both stiffnesses होती हैं. ठीक है. In plane stiffness बहुत ज़्यादा होती है because they have very high in plane dimension as compared to out plane dimensions. Out plane अगर आप slab की thickness देखेंगे, it is like 5 inches, but in plane dimensions देखेंगे, it is like 12 cross 25, 12 फुट बाय 25 फुट का पैनल है, उसकी 5 इंच थिकनेस है. सो 5 इंच थिकनेस, उसकी आउट ऑफ प्लेन थिकनेस कम है, आउट ऑफ प्लेन स्टिफनेस भी कम होगी, but still it has some stiffness. So shell is the thing which have in plane and out of plane stiffness. Similarly, we have plate which have only out of plane stiffnesses. अच्छा जी, ये हमने एनालिसिस की टाइप्स पढ़ी थी. दैट दीज आर द डिफरेंट पॉसिबल एनालिसिस. जिस तरह आपके पास स्टैटिक हो सकती है एक चीज़, इन लीनियर हो सकती है. द डिफरेंस इन स्टैटिक एंड लीनियर इज बीइंग शोन हियर. what is meant by linear thing and what is meant by static. Static means the load is being applied at once. यानी उसकी आपने एक वैल्यू अप्लाई कर ली and the intensity is not changing with type. It is static. Dynamic is mean with the passage of time the load intensity is changing. Like जिस तरह wind loads हैं, earthquake loads हैं, they keep on changing with passage of time. ऐसा नहीं है कि they remain same. So different possible combinations. ये हो सकती है linear elastic, हो सकता है non linear elastic, हो सकता है linear static analysis, non linear. ये सब possible जो आपके पास seismic analysis, these can be done in Etabs. This is the viewing option. Like once you perform the analysis, you are able to see the shear force and bending moment diagram. See in the bottom diagram, they have the BMD diagrams for all these members. In the top, you have shear force diagrams going on. Addition to these shear force and bending moment diagram, you can see them in contours, in the form of contours. में भी आप इसको देख सकते हैं. The red things they are showing, there are more stresses in this region, and less stresses are being shown with the blue color. तो बेसिकली जिस तरह ही आपको पता है कि कॉलम्स के पास चूंकि लोड्स ने ट्रांसफर होना है, सो मोस्ट ऑफ द forces they will concentrate nearby the columns, so you will see dark color regions near this column area. So you can see this in a contour map. This is called contour map. Let me just let it go. Okay, this is for this basic introduction. So in next section we will just go directly into Etabs. I will open Etabs for you 9.7.4 version, and we will actually see what are the different commands and things over there. ठीक हो गया?